Subscribe to Farm Logic right now, because what you're about to hear is not gardening folklore or trendy compost hype. It's a documented soil practice older than most modern nations, and once you understand it, you'll never look at dirt the same way again. I'm sharing this because if you care about historical agriculture, long-term food security, or survival methods that actually worked for centuries, this episode will change how you feed plants forever. Today, I'm breaking down what happened when I tested a 500-year-old soil ferment technique that farmers relied on long before synthetic fertilizer existed, and why the results were explosive, predictable, and deeply rooted in history. For most of human history, soil fertility didn't come from bags, brands, or laboratories. It came from controlled decay. Across Asia, Eastern Europe, and parts of Africa, farmers developed soil ferments by intentionally feeding microbes before those microbes ever touched crops. These weren't compost piles left to chance. They were living brews designed to unlock nutrients, suppress disease, and rebuild exhausted land. When I replicated one of these methods using historical records and traditional ratios, the plants didn't just grow faster. They grew differently, with thicker stems, darker leaves, and deeper root systems. This ferment works because it feeds soil life first, not plants directly. The method I tested is, well, closest to what Korean and Chinese farmers were doing over 500 years ago, long before the term microbiology even existed. They used fermented plant matter, carbohydrate sources, and native microorganisms to pre-digest nutrients. The soil, you see, essentially receives a living workforce that continues working for weeks after application. That's why growth doesn't spike and crash the way it does with chemical fertilizer. Here is how the ferment is traditionally built, and you know why each step matters. Fresh green plant material is chopped and lightly bruised to expose sugars. This can be weeds, crop trimmings, or fast-growing leaves. Historically, farmers favoured vigorous plants because they carry more active microbes. The plant matter is packed loosely into a clay pot or wooden vessel and layered with a natural sugar source like raw sugar, honey, or crushed fruit. The sugar isn't plant food, it's microbial fuel. This mixture is covered, not sealed, and left in a shaded, warm place for 5 to 7 days. During fermentation, beneficial bacteria and yeasts multiply rapidly. The smell changes from fresh green to sweet and slightly sour, which is, well, exactly what historical texts describe. When the ferment reaches this stage, liquid begins to pool at the bottom. That liquid is the active concentrate. I diluted it, roughly 1 part ferment to 20 parts water, which aligns closely with old agricultural ratios recorded in East Asian farming manuals. When applied to soil, the effect is not instant leaf burn or forced growth. Instead, within about a week, plants begin producing stronger new growth. In my test beds, leafy crops deepened in colour and woody plants began pushing lateral branches instead of weak vertical shoots. This is consistent with what historical farmers valued most: resilience rather than speed. The microbes convert locked nutrients into plant-available forms over time, which stabilizes growth. What surprised me most was how this ferment corrected poor soil rather than just feeding plants sitting in it. In compacted ground, earthworm activity increased noticeably within 2 weeks. That's not coincidence. Fermented inputs attract decomposers that physically restructure soil. This is why ancient farmers could maintain the same fields for generations without collapse. They weren't extracting nutrients, they were cycling them. You can apply this method today, whether you're growing vegetables, fruit trees, or survival crops. For a backyard garden, apply the diluted ferment directly to the soil around the root zone every 2 to 3 weeks. For trees, pour it at the drip line where feeder roots live. Historically, farmers avoided applying it to leaves, and modern testing confirms that soil application is where the real benefits occur. One practical example is using this ferment to revive tired garden beds. Instead of adding compost and waiting months, you simply apply the ferment at planting and again mid-season. Another example is seedling establishment. Soaking transplant holes with the diluted ferment before planting reduces shock and accelerates root colonization. This, interestingly, mirrors historical rice farming techniques where fermented soil teas were poured into paddies before transplanting. This method also explains why industrial farming struggles with soil collapse. Synthetic fertilizers, you see, bypass microbial systems entirely. Ancient soil ferments do quite the opposite. They strengthen the underground ecosystem so plants can regulate their own nutrition. That's why growth looks balanced instead of forced. Leaves are thicker, pest pressure is lower, and water retention, well, it improves naturally. The real lesson here isn't just about fermentation. It's about remembering that agriculture was once biological, not chemical. Farmers 5 centuries ago didn't just guess. They observed patterns over generations. This ferment survived because it worked, not because it was fashionable. When I tested it, the results followed historical logic perfectly. If you want more deep dives into forgotten farming systems, survival agriculture and historical methods that still outperform modern shortcuts, make sure you're subscribed to Farm Logic. Share this episode with someone who still thinks old farming knowledge is obsolete. And let's keep these methods alive by using them, not just talking about them.